Hello, students. Assalamu alaikum. Uh, this is our third lesson in the series of operating system. The topic of today's class is process scheduling algorithms. In lesson number 2, we have discussed a number of different concepts related with process. Uh, let's have let's have a quick recap of the previous class. In previous class, if you remember, we have discussed about waiting time, the time which process has to wait, total time a process has to wait. Waiting time is the total time which a process has to wait during its execution and completion. And the response time is the time when first time when the CPU time is given to any process. Burst time is the total time required from the CPU to complete any process. Then completion time, the time at which any process gets complete. Then turnaround time is the total time taken by a process to complete, which includes waiting time also. Now after this we have discussed process scheduling, and then I told you about priority also. That different processes may have different priorities, and it also depends on the scheduling algorithm that which process will be prioritized and given time of the CPU. Then we discuss about the process control block, and we have seen that a number of different elements which are stored in the data structure of process control block. Then we have seen different states of the process. So now in today's lesson, we will discuss about process scheduling algorithms, and we will see some numericals that by using different algorithms, how much time is taken by any process, or how much time a process has to wait to get CPU time. So these times are very important. If you don't have clear concept of these time, then you will have difficulty. So please make this thing very clear. We are going to use some formulas also. Waiting time is equal to turnaround time minus burst time. And what is turnaround time? Turnaround time is the exit time at which any process gets complete minus arrival time when the process comes. So you can also say that burst time plus waiting time is turnaround time. So this is the total time which a process takes to get itself complete. Then using the same formula, we can calculate waiting time also. Waiting time is turnaround time minus burst time. Similarly, burst time is equal to turnaround time plus waiting time. And completion time or exit time is equal to turnaround time plus arrival time. So you have to keep these times and formulas in your mind and make the concept very clear, because we have to use them when we will solve numericals. As I have told you before, that CPU can use different algorithms to schedule different processes. These algorithms might be first come first serve. So as any process comes in the queue, CPU time is served to it, and similarly when second come, then it has to wait for the first process. When the first process gets complete, then second is completed or not. Then shortest job first scheduling. Shortest job first scheduling means that the job which requires least time by the CPU, it is given priority, and it is given chance to complete its task. So here in both of these, first come first serve and shortest job first, non-preemptive approach is used. Non-preemptive approach or non-preemptive mode means, as I have told you in previous lessons, that quantum is not divided, CPU quantum is not divided, and the process is given full chance to get itself complete. So until unless the process which is in execution is not complete, other process is not given chance. So they both are non-preemptive approach algorithms. Now come to the third one, shortest remaining time first scheduling. It means that the process which has the shortest time remaining, that is given priority, and that is preemptive. Means that, for example, the process which is going on is in process of execution, and the other process which come requires lesser time of the CPU, then it will be given priority. And then the last one is round robin. In this algorithm, the CPU time is divided equally, and every process which is in the ready queue is given equal time. So these are the four different algorithms which can be used. Now we are going to see different numericals given in your book, and we have to calculate average turnaround time and average waiting time using different algorithms and different modes. About modes, I have told you there are two modes which can be used. One is preemptive and one is non-preemptive. In preemptive mode, CPU time is divided, and time slice or quantum is given to any particular process. In non-preemptive, a process takes the full time for completion, and until unless a process in execution is not complete, other process is not given CPU time. So let's see the first question. The first question is to calculate average turnaround time and average waiting time using FCFS, and the table is given in which a number of processes are in queue, and their burst time and arrival time is given. So first of all, to make it more clear, we have to make uh, a Gantt chart. The Gantt chart is given in your book. I have copied this Gantt chart from your book because the algorithm is first come first serve basis, and you can see that process 1, process 2, process 3, process 4, there are 4 processes, and their burst times are 23 millisecond, 4 millisecond, 9 millisecond, 3 millisecond respectively. Similarly, arrival time is the first process is coming at 0 millisecond time. Process 2 is coming on 1 millisecond time. Process 3 is coming on 2 millisecond time, and process 4 is coming at 3. So now we have to use formulas. As I have told you about the formula, we can uh, draw this Gantt chart. As you can see that it is starting from 0 time, and at 0 time the process 1 has come to take CPU time, and it is CPU time is served to it, and it takes 23 milliseconds to for completion. Until unless it is not complete, although other processes also have come in the queue, but first it will be completed, then other process will be given time. Then P2, which is on second number, given time, and it will take 4 milliseconds complete to be completed. Then P3 has come, and similarly P4 has come. So the P1 has taken 23, then P2 has taken 4 millisecond, 23 plus 4, 27, and P3 has taken 9 millisecond, 27 plus 9, that is 36, and P4 has taken 3 millisecond, 36 plus 39, 36 plus 3, 39 millisecond. So the completion time of P4 is 39, completion time of P3 is 37. So similarly, completion exit time of P4 is 39, of P3 is 36, exit time of P2 is 27, and exit time of P1 is 23. Now we have to calculate the turnaround time. As I have told you that turnaround time is equal to exit time minus arrival time. So we have seen the exit time, we have calculated the exit time of every process. We can calculate the turnaround time of every process now. So what we can do, we can put the value in the formula. For first process, the exit time is P1. For P1, exit time is 23 and arrival time is 0. So 23 minus 0, that is equal to 23. Similarly, for second process P2, exit time is 27 and arrival time is 1. So 27 minus 1, that is equal to 26. Similarly, for P3, exit time is 36 and arrival time is 2. So it will become 34. Similarly, for P4, the exit time is 39 and arrival time is 3. So turnaround time would be 36. Now to calculate the waiting time is equal to turnaround time minus burst time. So turnaround time we have already calculated, burst time is given. Now we can very easily calculate waiting time for for each process. So turnaround time for first process is 23 and the burst time is also 23. So 23 minus 23. So waiting time for first process is 0. Similarly, turnaround time for second process is 26. Burst time for it is 4. So 26 minus 4 is equal to 22. Similarly, for third process, turnaround time is 34. 34 minus 9, that is equal to 25. For fourth process, 36 minus 3, that is equal to 33. Now we have calculated turnaround time and waiting time for every process. Now very easily we can calculate average turnaround time and average waiting time. Just add all these and divide by 4. You can calculate average turnaround time, and similarly for average waiting time, just add all these waiting times of all processes and divide by 4. So average turnaround time is 29.75 millisecond and average waiting time is 20 millisecond. So this is how you can calculate average turnaround time and average waiting time for a schedule for Now come to the next one. The situation is same. There are 4 processes. Burst time is also same and arrival time is also same. But the algorithm has been changed. That is shortest job first. It means that the process which requires the least time of the CPU will be given priority and will be put in the queue. So, but in your book, the solution which has been given, that doesn't seem logical. What they are saying, that you can see the Gantt chart. In Gantt chart, what they are doing, they are putting process number 4 at first position, which is not possible. The reason is, at the time the process number 4 has come at the time of 3 millisecond, and at 0 millisecond time process 1 is coming. So at the time when process 1 is coming, no other process is in queue at 0 time. So when no other process is in the queue, there is no other choice except for P1. So I don't think that this Gantt chart is logical. So I have made the Gantt chart myself. It seems more logical, and I have consulted with others also. I have seen a number of videos and books, and they are using the same method which I am going to tell you. What they are doing, because this is for the shortest job first, at zero time, CPU does not have any choice, or scheduler does not have any choice except for the P1, because this is the only process existing in the queue. So it will be put in the execution. CPU time will be given to it, and at 1 millisecond time, second process is coming. Now, because the mode which is being used here, that is non-preemptive. Non-preemptive means until unless the job is not complete, other process cannot take CPU time. So in this case, what is happening, that first process will take its whole time to be completed, and till that time other processes would have come in the queue. So first 23 milliseconds will be given to P1, and during this time other processes are also in the queue. So after 23 seconds, it will be seen that which process has the requirement of least CPU time. So you can see P4 requires only 3 milliseconds. So it will be put in the queue, ready queue, and given a CPU time. It will take its whole time to complete its job, and because it requires 3 milliseconds, so 23 plus 26, 23 plus 3, that is equal to 26. Similarly, after its completion, P2 will be prioritized, and it will be put in the execution, and it will take 4 milliseconds. So 26 plus 4, that is total 30 milliseconds. Then after that, at the end, P3 will be given chance, and it will complete its job. So total we have the 39 milliseconds when all these jobs are being completed. So P3 has exit time 39, P2 has exit time 30, P4 has 26, and P1 has 23. So turnaround time for P1 is 23 minus 0, so that is equal to 23. Similarly for P2, 30 minus 1, that is 29. Similarly for P3, 39 minus 2, that is 37. And for P4, 26 minus 3, that is 23. So this is how turnaround time will be calculated. Now to calculate waiting time I have told you turnaround time minus burst time. So for first process, the turnaround time is 23 minus burst time, that is 23. So 23 minus 23 is equal to 0. For P2, waiting time would be 29 minus 4, that is 25. And for P3, turnaround time is 37 minus 9, that would be equal to 28. Similarly for P4, turnaround time is 23 minus 3, that is equal to 20. So this is how we can calculate turnaround time and waiting time for every process. And to calculate the average turnaround time of all, just add and divide it by 4, so you will get here 28 milliseconds. And for average waiting time, again add all these and divide by 4, and you will get here 73 milliseconds. At this point we will end our lesson here. In today's lesson we have discussed only two algorithms for process scheduling. One is first come first serve basis, and second one is shortest job first. In next class inshallah we will see rest of the algorithms. These are round robin and shortest remaining time first. So see you in next class.
Allah Hafiz.